NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will solve the inequality 1 over x is less than the square root of x, using a clear geometric picture. We'll first find where the two curves meet, and then use the graph to decide where the inequality holds. First, consider the domain. The square root of x requires x to be greater than or equal to 0, and 1 over x is undefined at x equals 0. So our common domain is x greater than 0. Let's draw the axes and the two curves in the first quadrant. The blue curve is y equals the square root of x. The red curve is y equals 1 over x. To locate where the graphs cross, set the expressions equal. 1 over x equals the square root of x. Square both sides, valid here since both sides are non-negative for x greater than 0. We get 1 over x squared equals x. Multiply both sides by x squared to obtain x cubed equals 1. So x equals 1. Now, we compare the heights of the two graphs. We want the region where 1 over x is below the square root of x. Try a test at x equals 4. The blue value is 2, the red value is 0.25, so the blue is higher there. That means the inequality is true for x bigger than 1. For a point between 0 and 1, say x equals 1/4. The red value is 4 while the blue value is 0.5, so the inequality is false there. Therefore, the solution is x greater than 1. We'll mark it clearly on a number line. Final answer x is greater than 1. The region to the right of 1 satisfies 1 over x less than the square root of x is greater than 1. The region to the right of 1 satisfies 1 over x less than the square root of x is 1 over x less than the square root of x. In this lesson, we will solve, using an intuitive geometric method, the inequality square root of negative x plus 2 is greater than or equal to the absolute value of x minus 3 minus 1. We'll graph both sides, find where they meet, and read the solution interval from the picture. Let's draw both curves. I will graph y equals square root of negative x plus 2, and y equals the absolute value of x minus 3 minus 1. Notice, the square root only exists when negative x plus 2 is non-negative, which means x is less than or equal to 2. We'll also mark the vertical line x equals 3, because that is where the absolute value changes its expression. The inequality holds where the green curve is above or equal to the orange V shape. To find the boundary points, we solve the equality. Square root of negative x plus 2 equals absolute value of x minus 3 minus 1. Split at x equals 3. For x less than 3, the absolute value opens as 3 minus x, so absolute value of x minus 3 minus 1 becomes 2 minus x. Write the case and substitute. Now square both sides. Both expressions are non-negative on this case interval, so squaring preserves equality. After squaring, we get negative x plus 2 equals the quantity 2 minus x squared. Expand and collect like terms. Factor the quadratic to find the intersection x values. We get left parenthesis x minus 1 right parenthesis times left parenthesis x minus 2 right parenthesis equals 0, giving x equals 1 and x equals 2. Both satisfy x less than 3, and also the square root domain x less than or equal to 2. For the inequality greater than or equal to, we need where the green curve y equals square root of negative x plus 2 is on or above the orange graph, y equals absolute value of x minus 3 minus 1. Looking at the picture, that happens between the intersection points 1 and 2, inclusive. Let's highlight the solution on the x-axis. In this lesson, we will solve the inequality. The square root of x minus 1 is less than the absolute value of x minus 1. We will use a clean geometric method. First, compare the two graphs, then confirm the intersection points algebraically. Let us draw axes and plot the two functions. We will graph y equals the square root of x minus 1 in light blue, defined only for x greater than or equal to 1. Then we will graph y equals the absolute value of x minus 1 in red across the whole axis. These two curves meet where the square root equals the absolute value. Visually, That happens at x equals 1, the shared starting point, and again near x equals 2. To understand the inequality, look where the blue curve is below the red curve. That will satisfy square root of x minus 1 less than absolute value of x minus 1. Now confirm these intersection x values algebraically, following a careful sequence of equalities. Set the square root equal to the absolute value, then square both sides. We obtain x minus 1 equals the quantity x minus 1 squared. Move everything to one side to factor. That gives the product of x minus 1 and x minus 2 equals 0. So the two solutions are x equals 1 and x equals 2. Because the square root is defined only for x greater than or equal to 1, we check two intervals, from 1 to 2 and from 2 to infinity. For x larger than 2, the blue curve sits below the red curve, so the inequality is true. At x equal to 2, the two sides are equal, and for x between 1 and 2, the square root is above the absolute value. Therefore, the solution is all x strictly greater than 2. On the graph, the highlighted orange ray along the x-axis marks the solution set x bigger than 2. That is our final answer. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.